Solving exponential equations. Given this equation right here, I know that it's exponential because it has an exponent. It does not have a log in it. It does not. Your job is to get the base alone. That is step one. The base here, you have to identify the base is e. 5 is not part of the base. So I'm going to move the 5 by dividing it out of there. 10 divided by 5 is 2. E to the 4x is still there. My second job is to isolate the exponent. Because it's unknown, notice it has an x with it. And the way that I do that is with a log. Isolating an exponent is a log's job. So, they wrote natural log. Here's why. Natural log and e is its base. So if I have e, I take the natural log of both sides. If this just had a 4 as the base, I would take in the log of both sides. We'll do some in a minute. The natural log of 2. Remember, exponent rules say that an exponent resides out front. So I have isolated the exponent by bringing it out front. Natural log of e cancels itself out. Because this is its base, they cancel one another out. So I've got the natural log of 2 is equal to 4x. So I need to type that in my calculator. Natural log of 2, enter. And I'm going to divide by 4 because I'm trying to get x alone. Then I can round. Notice they rounded to the thousandths. You can plug that in to check it. So 10 equals 5 e to the 4 times 0.173. In my calculator, what I type is 5 second natural log, there's your e, 4 times 0.173. 9.9 is about 10, and the reason it's not exact is because I rounded. So that one's done correctly. Let's work a second one. Notice my base here is 5, and it needs to be alone. So I'm going to add 4, and 7 plus 4, I don't know what they're doing there. 7 plus 4 is 11, so just come straight down here and skip all that. Notice the base is alone. The base is 5, and so step 1 was to get the base alone. Step 2 is to isolate the exponent. In order to do that, I have to take a log. Notice they did log of 5x and log of 11. Write this correctly. The exponent comes out front. In order to get x alone, they're showing you're going to divide by log of 5. So this is log 11 divided by log of 5. It's change of base. So log 11, close the parenthesis, divided by log of 5. And x is already alone, so this is 1.48. Oh, you got to round correctly, and we're rounding to the thousandths here. They told me right there. So 1, 2, 3. That 8 makes that a 10. So this is 1.490. Again, I can check that. So I'll go back to my original problem. 5 to the 1.49. Minus 4, and we want that to be 7. 5 raised to the 1.49 minus 4. Notice that that is just about 7, and again I rounded, so that is why it's not exact. So let's try another problem. Another 2 problems, I should say, and then we can work on word problems. Let's do this problem first. The base is 6, and it's already alone. So after the base is alone, my job is to isolate the exponent. What isolates an exponent is a log. It doesn't say log, so I'm going to introduce a log now. Log of 6 to the 3x equals, I must do the log of both sides. What I do to one side, I do to the other. So don't forget your exponent comes out front. That's exponent rules. If I'd seen it out front, I would have put it up there as an exponent. Now I'm trying to get x alone, so we're going to divide by the log of 6. So 3x equals log of 12 divided by log of 6. It's not 2. It's not 12 divided by 6. These are logs. This is a decimal divided by another decimal. Do not round. Leave the decimal in your calculator. And now I'm going to hit divided by to get x alone, 3. X is about 0.462. 3 decimal places, the thousandths. Okay, given the second problem, my base is E, and I have to get E alone. So we're going to subtract 5. What I did to one side, I did to the other. Same thing happens with logs. If I introduce a log on the left, I introduce it on the right. This should be 75. Again, the base is E, so let's get rid of the 2 by dividing. 75 divided by 2 is 37.5. Now, I have an exponent. I don't know what it is. To isolate an unknown exponent, I need log. In this case, I need natural log because the base is E. Exponent comes out front. Natural log of E, that is its base, so it cancels out. So I'm left with x minus 1 is equal to the natural log of 37.5. Let's take the natural log of 37.5. Do not round. We still need to add 1, so I'm going to go ahead and hit plus 1 in my calculator. Now I can say x is about 4.624. Alright, exponentials. They have no log written in them, so I introduce a log to both sides. Exponentials are used all the time in the real world, especially about money and percentages that you're gaining or losing. Super important. Suppose you deposit $250 into an account that pays 4.5% compounded quarterly. Quarterly is every 4 months. And they give you the equation you need. They tell you that A is the amount in the account. N is the number of quarters. Your initial investment is P. And your interest rate is R. That's a whole lot of letters. And what they want to know is how long will it take the account to contain at least 500. You started with 250. A is after some time. P is initial. There's what I need. 250 is P. Now the 4 is already there. And R is your rate. My rate is 4.5%. To plug that in, you have to change a percent to a decimal. That's 0.045. The decimal moves 2 places. This is out of 100. 2 places to the left. Make sure you change that correctly. So for N, okay, so that means I don't know what N is. They want to have at least $500, so that must be your A. I'm trying to get N alone. PEMDAS says parentheses first. So I'm going to type in my calculator. 1 plus parenthesis 0.045 divided by 4. That whole thing, do not round it off, goes in there. My goal is to get N alone. This decimal that I just got is the base. I need the base to be alone, so we're going to divide by 250. So 500 divided by 250 should be 2. It is. Now, I have the base alone. It does not say log in this problem, but I need to isolate this exponent, so I'm going to take the log of both sides. What I do to one side, I have to do to the other. Before I'm finished, I need to bring the exponent out front. That's log properties. Go back and watch that video if you need help with that. Log properties. To get N alone, I'm going to divide by the log of 1.1125. divide by the log of 1.1125. N is about. These will cancel. So when I get my answer, I can round. Log 2. Close the parenthesis. N is about 6.5. That tells me that I have about 6.5 quarters. That's important because we're talking about quarters and not months. So we need to be able to translate and change that. Alright, working this problem, I knew something was wrong because you can't have 6.5 quarters. So I went back, I looked at my math up here, and when I did 0.045 divided by 4 plus 1, I left out my 0 right here. So that means this should be 1.0, 1.0. So when I do my division now, and that was my mistake there, I overlooked the decimal, log 2 divided by log of 1.01125. That's much different. There we go, 61.96. That's what we're going to say. So it's about, we could say it's about 62 quarters. Quarters is every 4 months. So I need to do 62 times 4 to find out how many months I've really used up. 62 times 4 is 248 months. And I don't ever talk about months like that, so I'm going to divide by 12 because that's months in a year. So let's see how many years we have. So we have 20 months. Sorry, 20 years, not months. This is years. 20 years. 20.7, really, years. Or almost 21 years. Now think about this. This is a real-world problem. You put in $250, you want to get it to $500. It's going to take you 20, almost 21 years to save that much money. I suggest you find a better interest rate because that is not good. You've doubled your money in 21 years. Not good. Not for that amount. Okay, let's do another example. How long will it take to triple the $250 investment? So we're working with the same formula, which said A equals P times 1 plus R over 4 to the N. So we want to triple it. My initial is 250. My interest is still 0.045 over 4 to the N. To triple 250, that means we take 250 and we multiply it by 3. That's 750. Right here, you should already know this is 1.01125 because we just did it in the last problem, and I had messed it up. 1.01125. To get rid of 250, you're going to divide it out of there. You should know 750 divided by 250 is 3 because you just doubled that. I'm sorry, tripled that. So we got 1.01125 to the N. Again, we're going to log both sides. And I'm going to go ahead and move the exponent as I log, because by now you should know that should be happening. So you don't have to write that as two separate steps. Go ahead and divide by log of 1.01125. 1.01125. Log of 3 divided by the log of 1.01125. Yes, I've typed that correctly. So this is going to be 98 quarters. Again, I'm going to multiply that by 4. That's 392.8 months. Divide that by 12. It's 33 about years. Yow! 33 years to go from $250 to $750. That is not good. You can now go work on your assignment.